Good morning everyone. I am Kakasai Bagmare giving presentation on the review of in situ torsional direct shear test device under the guidance of Dr. K.K. Tripathi. In this presentation I will review, I am going to explain some of the field test which is available in the market, as well as I will try to explain you the different disadvantages or difficulties while performing that test, and I will tell you how the new equipment is required to test the shear strength parameters of the soil. So we know that the bearing capacity is very important while constructing any structure, and the shear strength is the one of the phenomenon of that. The shear strength parameters, that is cohesion and angle of internal friction, C and phi, are the major parameters of the shear strength. So and we can determine the shear strength, or we can measure the parameters of shear strength by using direct shear test method, triaxial test method, vane shear test method, and etc. But the laboratory direct shear test method is very useful and used to it is very simple to perform for the sandy soil or sand particles, because it's very simple to perform, and it may be but we know that it can be conducted under controlled conditions which may be differ from the actual site condition. That's why we are think that we go for the field testing. Yes, field vane shear test is also available, but in field vane shear test we cannot apply the normal load on the soil, because there is no provision to apply the normal load. Hence that field vane shear test is only applicable for the cohesive soil. That's why we can find only the C value of the soil. So the main objective of this study is to perform or to study the different methods of field shear testing, and do the comparative assessment for their suitability and the adoptions. So my first test is the very well-known test, that is ASTM D4554 2006. This test is used to find the discontinuities of rock. You can see as a specimen in a rock, and like our similar testing, that is direct shear testing, we apply the normal load and corresponding shear load at failure we can find. Here also you can see we can see that from the reaction column they apply the normal load, and hydraulic jack they apply the shear load. But before performing, or before we can say the making the specimen, they must confine that specimen with the concrete. So reinforced concrete pad you can see at the surrounding of that rock, and so that we can say it's very difficult to perform these kinds of tests, as the heavy equipments are required, heavy load or reaction column is required to perform these kinds of testing. Another test which is well-known test is Indian Standard 2720 1979 Part 39 Section 2, the direct shear testing, field direct shear testing. Basically here they excavate the soil sample 1500 by 1500, and they left out the two soil specimen, or two soil, we can say the specimen both the side, and with the help of sandbags they use for the normal loading. On the both soil they put the sandbag, and with the help of hydraulic jack they try to push the another soil mass, and with the help of that probing ring they measure the lateral, we can say, the load which is required. But we can see that the heavy excavation is needed in this study, as well as it can be a very difficult to provide or left the exact, we can say, the specimen, exact size of specimen and all. Another modified direct shear testing, in this test the lattice shear frame is inserted into the soil, and dead load system they put as a normal loading, and with the help of chain and rope system and the heavy machinery they try to pull the entire lattice frame, and whatever the required shear force they measure by the load cell. The similar test we can see here also. The open sided shear box, they again pull that entire assembly with the help of winch and auger system, and they measure the whatever the required shear load by the probing ring. Also these two testing, if we compare these, I can say that we can perform these kinds of testing at the top surface only, but not at the we can say the below the ground level. Or if we want to perform the below the ground level, it is very difficult. Then these two tests, which is quite similar to like ASTM test, again these two tests are useful to find the discontinuities of rock, or we can say the for the rock pile also. Here also we can say we can see the normal or loader is used to apply the normal load on the both the cases, and roller plate is used as a to transfers the normal load to the specimen. Again the hydraulic jack is used to apply the lateral thrust, or we can say the lateral force. Again these testing very, we can say, the laborious testing, and very heavy equipment is needed while performing these kinds of tests. As we compare that, as I mentioned, that all that whatever the test we saw, these all tests are the heavy set that require the heavy setup. It requires heavy construction equipment. Some of the tests are some of the tests maybe the calculation is very complicated. Some of the tests we can perform at the shallow depth only. So or we can say they require a number of labors to perform that test. Also one more factor is very important, that is strain rate. One of the study in 2006 they conclude that there is the considerable effect of the strain rate on the shear strength of soil. As we know that the laboratory direct shear testing is a strain control test, and from this study they conclude that there is a considerable time required to rearrange the particles. So, and whatever the test we saw in earlier slides, that test are almost all the tests are the stress control test, including ASTM test and IS code test. So then I can say that all the tests, whatever the tests are popular tests, that are the stress control test, and yes, there is a considerable strain rate influence on the shear strength of soil. Then field shear test should be simple and strain control test, as similar to the laboratory direct shear test, and the all present tests are the required heavy setups and considerable manpower. That's why they making them expensive. So we trying to design one setup, that is torsional direct shear test, which is similar to wind shear test. This setup we can use in the field also. Here the vein of 90 mm depth vein we insert into the ground or soil which is to be tested, and with the help of vertical column and the hydraulic jack system we apply the normal load at the bottom or on the soil which is to be tested, and with the help of lever arm, the wire rope and the PMDC motor we apply the torsion or torque or twisting moment to the soil. Whatever that means the PMDC motor which we use, that PMDC motor having a constant strain rate which is lesser than the laboratory direct shear testing. So from this we can trying to find the shear strength parameters of soil. So I conclude that the whatever the field testing is there, that field testing should give the comparable results with the laboratory direct shear test for the coarse grain soil. It should be strain control test. It should be the lightweight setup that can be performed from the field also, that can be performed field without electricity, and we can say the whatever the I mentioned, the field torsional direct shear testing that has all the virtue of laboratory direct shear test device, and thus make it widely acceptable and adopted. Thank you. These are my references. If any questions, you are welcome.